Now that we have some basic R knowledge under our belt, let's try to gain some insights into the safety of different states in the context of gun murders. We want to rank the states from least to most dangerous. The function sort sorts a vector in increasing order. So we can see the largest total number of gun murders by simply typing sort and then murders $total. And we can see that the state with the smallest number of murders had 2, and the one with the most had 1,257. However, this does not give us any information about the states, only about the totals. The function order is closer to what we want. It takes a vector and returns the indices that sorts that vector. This may sound confusing, so let's look at a simple example. Consider this very simple vector of 5 numbers, 31, 4, 15, 92, and 65. If I type sort, it puts them in order, 4, 15, 31, 65, 92. Rather than sort the vector, the function order gives us back the index that, if used to index the vector, will sort it. So if I type index and I assign order of x, now if I index x by that index, I get back the sorted numbers. If we look at the object index, we see why it works. Look at x, 31, 4, 15, 92, 65. If I type order x, I get 2, 3, 1, 5, 4. This is the index that puts x in order. 2 is the first entry because the second entry of x is 4, which is the smallest number. The second smallest is 15, which is in the third location. So 3 is the second entry of order x, etc. So how does this help us order the states by murders? First, remember that the entries of vectors you access with the $sign follow the same order as the rows in the table. So, for example, these two vectors containing the state names and state abbreviations respectively match their order. We only show the first entry so that it fits on the screen, but notice that we have Alabama, Alaska, Arizona, etc., and in the other one we have AL, AK, AZ. Those are the abbreviations that goes with those 3 states. And if you look through all 10, you see that they match. This means we can now order the state names by their total murders by first obtaining the index that orders according to murder totals, and then indexing the state names or abbreviations using that index. Let's type it here. Let's define index with the order of the totals, and then index the murders abbreviations to see the states ordered by murder totals. We see that Vermont has the lowest total and California has the most murders. Now, there's actually a much faster way of doing this, of getting the biggest or the smallest. If we are only interested in the entry with the largest value, we can use the function max. So max of the murders total gives us 1,257, the largest number. And which max gives us the index where this number resides. So if I define I_max as which.max of the murders total, I get back the index for which that value is 1,257. And now I can index the state names and get back the answer which we were looking for. California is the state with the largest number of total murders. For the minimum, we can do the same with min and which.min. So, is California the most dangerous state? In the next section, we argue that we should be considering rates, not total. But before doing that, we introduce one last order-related function, rank. For any given list, it gives you a vector with the rank of the first entry, second entry, etc. Here's a simple example. Let's look at that vector we defined earlier, 31, 4, 15, 92, 65. If I type rank of x, I get back 3, 1, 2, 5, 4. Why? Because 31, the first entry of x, is the third smallest value in x. 4 is the smallest, so that one gets a 1. 15 is the second smallest, so it gets a 2, etc. To summarize, let's look at the results of the 3 functions we have introduced. In the first column of this table, we have the original vector, 31, 4, 15, 92, 65. In the second column, we have the result of sort. In the third column, we have the result of order. And in the fourth column, we have the result of rank. Notice that the sort column simply has the original sorted. So we have the values going from the smallest to the biggest. Order, again, gives us the index needed to obtain the sorted data. So because in the sort column, the first entry is a 4, in order, we have 2. Why? Because if we go to the original, we need to go to the second entry to get that 4. In the second row of order, we have a 3. Why? Because to get a 15, the second smallest, we need to go to the third column of the original to get 15, etc. Now the final column, rank, gives us the ranks of the original vector. 31 is the third smallest, 4 is the smallest, 15 is the second smallest, etc. All right, now that we have learned about sorting in R, we have some useful tools to answer questions about the data at hand.